Hello everyone. Welcome to this tutorial on Python Basics. Today we are going to deal with logical and looping constructs and making decisions through if-else clauses. In our previous tutorial, we discussed about what logical operators are. How can we make logical expressions which results to a true or false value? In this tutorial, we are going to have some basic agendas as well. Our first basic agenda is understanding the structure of if-else clauses. Then we're going to make decisions based on those if-else clauses, nesting if-else clauses, and else-if ladder. So these are our basic agendas for this tutorial. That is what we exactly are going to encounter frequently in case if you are trying to create some if-else condition in Python. So let's hit the command prompt. I already created a tutorial. Let's try to see over here. So this is a syntax. This is a very basic syntax of an if-else place. In our first case, what we have tried to do is we have tried to create an if-case example. We have compared two values, and based on the logical operation and the resulting value, we tried to execute an arbitrary code. And in this case, we are trying to print, we just compared two values. Now, if you see 23 is certainly less than 45, so if this condition evaluates, either it's true or false. And if it's true, then it executes the code, which is followed by the colon operator and indentation. So this is the basic syntax. Be careful about the indentation. And also this colon operator, because people usually make mistakes of forgetting them. And in our next example, there is this that we have used, this else clause as well. So in the first if clause, we have a condition. Then we have this colon, and after that, we have written the code which we want to execute. So in this case, I'm trying to compare two strings. And if the strings are equal, then I'm executing the first code. But if conditions are not equal, then this code falls to the else clause and then executes the else block code. So the syntax is pretty simple. We are going to have if-else clauses. You're going to have a logical expression, and we're going to have a code block specific to each if or else clause. So as you can see that in our first example, I didn't mention the else clause. So just keep in mind that there could be an if clause without an else clause, which is logically possible, but there cannot be an else clause without an if clause. So let's try to execute this code. As you can see, the output it just printed me, we just compared two values. If you remember, when going into the code, we actually had this condition which evaluates to true. Therefore, it prints out we just compared two values, which was the code block of the if clause. Now in the second case, we have both if and else clauses, but since the condition is not true, therefore the flow of the program falls to the else clause. And it executes the code block of the else clause, and therefore that is why it printed both strings are not equal. As you can see over here, so this was about a very basic syntax of if clause. Let's take one more complex example. Let's take the same code and modify it a little. For example, let's try to put yet another if-else condition inside the else block and see if it can be done or not. So what I'm going to do over here is, if I have created yet another condition inside the else, and what it does is it compares moon equals eclipse. Since both strings are not equal, therefore, as per our assumption, the code block should fall to the else clause and it will print false. Let's try to run this code. And as you can see that it printed false. That was because our code went into the else block and it again encountered an if-else condition case. So it evaluated moon equals eclipse. That is false. Therefore, again, the code fell into the else block and it printed false. We can do this, and we can nest as much as possible theoretically, but practically you rarely find a case where is that much of nesting, maybe 2 or 3 levels. But beyond that, if you're trying to implement a code which does contain a lot of nesting of if-else cases, maybe probably you're doing it wrong, Or maybe you need an else-if ladder. Now, what is an else-if ladder? Let's have a look at it. Now, in most cases, we have a binary decision. For example, we can have two cases. We are going on a road and there are two turns, left or right. We have to decide either we go to the left or to the right. So both of the decisions might have their consequences, but that is not the case with real life. There could be a lot of possible decisions. For example, there could be 4 turns. Or let's take yet another example. There could be subjects, which you want to opt for your curriculum. So let's say if there are 3 subjects, physics, chemistry, and math, and you want to opt out any specific one of them. Now, this is not a binary decision because there are actually 3 values: physics, chemistry, and math. So a decision has to be made and an action has to be taken as per that. So what in this case, we can do one thing. We can do a nesting of if-else cases. But the issue with nesting is that the code becomes complex and not readable. So therefore, we use else-if ladder. Let's take an example. Here we have a very fair example of an else-if ladder. And here we get introduced with the method called raw input. What raw input actually does, let me describe it a little. It takes a value from the user. It pauses the program until the user doesn't enter some value, and then it stores the value into the variable applied. And the values here you see in the parenthesis. This is a string, which this method shows while taking input from the user. Now, if A equals Yoda, then we print Yoda, which is the first case. Then we have another case. If BA equals learning, then we print learning, which is a second case. So there are 2 cases. If it had just been about Yoda and learning, that means binary case, we might have simply put an else-if case. But we cannot put over here an else-if case because we have yet another third condition called A equals Python. So we can put multiple conditions like that. Maybe we want to add yet another condition. So we can put conditions like that on. And in the last case, we can put an else clause if none of the conditions works out. However, you can omit this else. But in logical cases, you might want to keep it, just to fall back from all those conditions. And in the end, you want to execute something. So let's try to execute this code and let's see what happens. So it's asking me for a string. And as you can see over here, enter any string. Which of the same string which has provided to the raw input method in the parenthesis. Now let's try to enter Yoda. So let's print Yoda as per expected. Let's try to put something else. Maybe sample. Well, there seems to be some error in the code. Let's try to find the bug. Well, very luckily, this is our first bug. Let's see what we have done wrong in the code. Not this one. Here, we try to print the sample. Now let's try to execute the code again. Let's enter sample and print out a sample. The error occurred because I didn't apply the quotation marks around the sample string. Now let's try to do something else. Let's put any other string, maybe random string, and then see. Well, this was not extracted, which as we can see, it is the same code, which is mentioned in the else clause of this else-if ladder. So I just explained the if-else clause, the nested if-else clause, and the else-if ladder. And this is sufficient for the time being. There will be more complex cases in our next tutorial, but for the time, we will move on to our further tutorials. So in our next tutorial, what we're exactly going to do is we're going to take lots of test conditions, and we're going to repeat them again and again using a code block. So what you have to do is to take real-time life decisions and turn them into if-else clauses and see that if it works out for you or if you're stuck somewhere.